Welcome back to the Data Stack Show. Today we are talking with Gleb from Datafold. Datafold is a data quality tool, and they have a super interesting approach to data quality. Kostas, one of my burning questions is around when to implement data quality tooling and processes in the life cycle of a company, because a lot of times, and you and I both know this from experience, you a lot of times approach it in a reactionary way, right? Like something's breaking, a dashboard breaks, you're trying to do some sort of analysis, you want to launch something new, and you run into data quality issues that really limit what you're doing. And so then you begin to implement those processes. And so I know that Gleb works with companies who are trying to tackle data quality all across the spectrum. And so I just want to hear from him, what does that look like today? Do you have to be reactionary? Is it worth the time cost it takes to do that proactively? So that's what I want to learn about. How about you?
Yeah, I want to hear from him, like, how do you start building a technology and a product around data quality? Because data quality is one of these things that's like so broad, and like there are so many like different ways that you can implement it, like in so many different like parts of the data stack where you can go and like start working out. So I'd love to hear from him, like about his experience in like starting like a business and also a new product around that, and like the hard decisions that you have to make in order to start. So yeah, like I think we'll start from there, and I'm sure that like we will have like plenty of opportunities to go much deeper into like the product itself and the technology and all the different choices made around it.
I agree. All right, well, let's dig in and talk with Gleb.
Let's do it.
All right, outro, take one. What an interesting conversation, Kostas. I think that my big takeaway, and I'll probably be thinking a lot about this week, is the initial discussion around anomaly detection, which I thought was really interesting, and how it was really helpful in some ways in his experience at Lyft, but then also fell flat in some ways within the company because of some inherent limitations. And then the more I thought about that in connection with the way that he described starting at the point in the stack where Datafold sort of solves the initial problem and then moving left and right with like in being involved in sort of the like pre-production process or the deployment process was really interesting. And I think to summarize that, it would be that anomaly detection, AI, all of that technology can be really useful, but ultimately you have humans involved in creating, managing, processing data. And so you have to have tooling that actually is interjected into the process that those humans are using. And Gleb seems to have a really good handle on that. And so that's just a really good reminder, I think, about data quality and the particular characteristics of trying to solve it.
Mm-hmm. Yeah, I agree. I think what I really like enjoyed from the conversation, what I'm going like to keep and probably like think a little bit more about it, is about the role of the data engineer. I think we are seeing like the data engineering discipline becoming like much more solid and well established as like something important around having your data infrastructure and working with data. But also it's evolution, like it's going through like a very rapid evolution right now. Like we heard that like from Gleb by saying like how couple of years ago you could, and when I say a couple of years, we are talking about like 2-3 years ago, it's not that far away. You could have like, as a data engineer, like the complete control over like your pipelines and the infrastructure. So it's like was like much easier. I mean, at least you had control over like what was going wrong. But that's not the case anymore. You have like so many different stakeholders and so many different like moving parts like in the infrastructure that makes it challenging, and it's part of the evolution of the role. So yeah, I think that's something that like we should investigate more in general.
I agree. Alrighty. Well, thank you for joining us on the DataStack show. As always, subscribe if you haven't. Tell a friend. We love new listeners, and we will catch you on the next one. Gleb, welcome to the DataStack show. We're so excited to chat with you about all things data and specifically Datafold.
Thanks for having me. Super excited.
All right, well, let's start where we always do. We'd love to hear, tell us how you got started in data with your career, and then what you were doing before Datafold. So yeah, we'd just love to hear about how the path that led you to starting Datafold.
Yeah, absolutely. So my original academic background is in economics and computer science, and I started my career around 2013 as a data engineer. Joined a big company called Autodesk, which focuses on the B2B software for creators. But at the time, they were putting together a consumer division, and I ended up essentially almost creating a data platform from scratch for that consumer division, tying all the different metrics from different apps that Autodesk acquired. And that was a really interesting time because if you remember, 2013 is where I think Spark was almost just released. Looker just went out of stealth. Same as Snowflake. So a lot of the tools and companies and technologies that we now consider really foundational at that time were, super early stage, super cutting edge. Sure. And so that was a really exciting time to tinker with data. And after a year at Autodesk, I moved to Lyft, where I ended up being one of the founding members of the Lyft's data team. And at that time, Lyft was in a super hyper growth stage. Data infrastructure was kind of barely there. So we had one Redshift cluster, and we're building everything on top of it. And wow. Things were constantly on fire. And I remember days when essentially entire analytics team would go get boba because Redshift was completely underwater by all the queries that everyone tried to run. And I initially was tasked with building all sorts of different data applications, from forecasting supply and demand to understanding driver behavior. But I was so frustrated with the quality, not with the quality, but with the tools that I had at my disposal. And that wasn't necessarily Lyft's fault. It's basically, at that time, what was available for data engineers in general off the shelf. The experience was quite terrible, from just not being able to run queries to not being able to test things, understand data, trace dependencies. All of that was extremely time consuming. And so I kind of gravitated naturally to building tools. First, some simple tools for my team members. For example, I built a dev environment where people could prototype their ETL jobs before pushing them to production. Before that, we kind of tested in production, which was really a bad idea. And I also had some really, really bad horror stories that I think led me ultimately on my journey to build Datafold. So one of them, which I quite often cite, is at Lyft we had this practice of being on call, data engineers being on call. Essentially, the data at Lyft has been so important that entire company pretty much ran either on fully automated decision making with machine learning, or meetings organized around reviewing dashboards, seeing how the company performed. And so delivering data on time by certain SLAs always has been super important. So that's why we had on-call engineers, making sure that whenever a pipeline was clogged or late, people could actually address that. So I was an on-call engineer one day, and I was woken up by PagerDuty alarm, I think 4 a.m. because there was some really important job that computed rides that failed. And so I was looking into the error and found some bad data that entered the pipeline, implemented a 2-line SQL filter, and pushed the change. Everything looked good. Did some quick sanity check. Got a +1 from my buddy, and then went back to sleep. Everything seemed normal and green, and then you kind of see where it's going. So yes, next day I came to work, and then probably 2 hours in the workday, I was forwarded an email from, I think, CFO that was looking at the dashboards, and everything was kind of all over the place, looking really weird. And so the craziest thing is not that I managed to break lots of dashboard. The craziest thing is that it took us about 6 hours of sitting in the war room with, me, a few other senior data engineers, and trying to understand what's going on. And it took us 6 hours to actually pinpoint the issue to the hot fix that I made. And obviously, if I was able to make such a trivial mistake and bring down so many tables and had a really big business impact with just a two-line SQL hotfix, if you extrapolate this to how much loss is happening just due to data breakage throughout the industry, it's actually enormous, and it's really easy to break things. And luckily for myself, I wasn't fired back then. I was actually put in charge of building tools to make sure that this exact error doesn't happen again. And so we introduced a real-time anomaly detection system that was helpful, and then focused on improving the developer workflow to make sure that developers actually don't introduce such issues into production. And one of the interesting learnings that I had back at Lyft that ultimately informed, I think, the way Datafold approaches the topic of data quality is that when we introduced, so the first reaction when we had this issue, and I was not the only one breaking things, was that we need a system that would catch anomalies in production. We need something that would detect when things are broken, because, well, we don't want CFO to forward us an email, dashboard screenshot and say, hey guys, I think this is wrong, right? This is a really bad situation to learn from your stakeholders. And so we implemented a really sophisticated real-time anomaly detection system that would compute metrics in real time using Apache Flink, both from our kind of ETL transformed data as well as some streaming, so events. And that was somewhat impactful, but we really struggled to get adoption and really struggled to make an impact with that as much as we hoped. And the ultimate problem was that that system was kind of too late into the process. So like by the time you detect something, it's kind of already broken. And so a lot of the teams kind of really struggled to see the value there. And the second challenge was that it in a way existed outside of workflow. So, if someone is going to introduce a breaking change like I did, right, or a bug, and they have to learn about this from a system that kind of detects this bug in production, they have to kind of drop everything, whatever they're doing. They have to go outside of the workflow and then focus on investigating whatever anomalies that system finds. And we found that disrupting the workflow is actually a really expensive way to get on top of data quality issues. And so we started focusing back, at Lyft to build tools that would actually prevent things from breaking. And that also informed what we're trying to do at Datafold. So our philosophy is in proactive data quality and shifting left, which means that as much as possible, we try to detect issues very early on in the dev process, ideally in the IDE when someone types SQL, but at least in staging or pull request review, not in production when things already do the damage. But that's another story. That's another probably question. But that's pretty much how I ended up doing Datafold.
Love the story. I'd love to dig into the adoption problems a little bit more, because I think that's really interesting, in large part because, there are a number of sort of data observability, data quality tools that are betting on anomaly detection as sort of the primary way, to solve that problem. Would you say, and maybe this is just me rephrasing what you already said, but would you say that the anomaly detection as you described it at Lyft was actually just a less manually intensive way of doing alerting, right? It was sort of almost like, a more efficient way of doing alerting, right? But alerting tells you that something is already broken. And that's why, people are just kind of like, well, we already are getting alerted when something's broken. The fact that we can do that more efficiently isn't exciting. Is that how you would describe that dynamic? Or I'd just love to know more about that adoption problem.
Yeah, I think there are a few challenges here. I think in general, alerting and monitoring is valuable. So we actually were able to detect really bad incidents in production where we would not do a really important step in the billing process, and that would have led to massive loss, financial loss for the company, who would basically not bill people for what part of their bill. And that system actually helped us detect not just data quality issue, but a real production issue. So definitely not discounting the value of alerting. I think the challenge is that a lot of the times we forget about where the data quality or general issues are coming from. And I like to think about this in a very simple form. So I think ultimately, when we think about data quality, although it's a very big topic and a large problem, it's ultimately either we break data or they break data. And when I say we break data, I mean that we, data team, maybe other data developers, people who actually do development on the data pipelines or touch data in various ways, introduce changes that, change the definition of things, like we change how a session is calculated, and then that potentially throws off all our calculus around conversion, right? Or maybe we change the schema of an event because microservice can no longer provide a given field, and then some machine learning model that relied on this is no longer, doing machine learning. Things like that, right? So that's kind of we break data. And then there's also a category which I call they break data, when external things happen. And those external things are, for example, we may buy data from our vendor, and that vendor ships us a bogus data set that doesn't include all the CDs, right? Just completely outside of our control. Or we have, let's say, we're running Airflow, and Airflow is known to have a really funky scheduler, and sometimes things don't get scheduled, or sometimes they may be marked as like completed, but actually left in a pending state, and not really our fault, like infrastructure fault. And so I think where data monitoring really is helpful is in detecting things that are in the they break data category, right? Things that are outside of our control, as well as maybe being like the last final defense for stuff that we break, that people break. But I think where we are really missing sometimes, like the counterintuitive challenge, is that we tend to attribute the failures to like external factors, where in fact it's us, like generally the people in the company, breaking things one way or the other. And so what I think the major learning for me was that we really need to invest in building systems that are more like anti-fragile and more robust to breaking. And that means potentially having better systems to how we do data in production, right? So like in general, improving how we orchestrate jobs and having data contracts. But the part where I am most excited about is improving how we develop data. So improving the development process, in particular, how we introduce changes to data products, right? Be that events, be that transformations in SQL or Spark, or even end user data applications like Looker dashboards or certain machine learning models. I think that's probably my bet, is that I see a huge opportunity in improving the status quo of everything is broken, in really improving the change management process. And then if you do that, then there are fewer things that are breaking in production. And the other challenges that we saw is data is inherently noisy, right? And it's always changing. And so when we're talking about data monitoring, we're talking about typically unsupervised machine learning, where a system would learn a pattern of data. And by pattern, I mean that can be anything from a typical number of rows that a data set gets daily, right? Or what is the distribution in a given dimension or metric column in a data set. And then when the reality doesn't conform to that baseline, we get an alert, right? But given that our business is changing, especially in high growth companies always, and given that we are operating in the world where not even a unicorn data team, not even at a unicorn startup, earlier stage, it's not uncommon to have thousands of tables in production and tens of thousands of columns. We can find anomalies there all day long, right? And the real challenge is, how do you actually identify what is important, what is worth fixing, what is a real challenge, what is a business issue versus data quality issue? And that's probably what really makes adoption of the quality platforms. That's what really held us back at Gleb with our real-time anomaly detection system. And that's why I also think change management is so important, is because if we can prevent preventable errors early on in the dev cycle, if we prevent them from getting into production, then we have less noise to deal with in prod, right? We just have fewer things to worry about.
Yeah, absolutely. No, that's super helpful. Well, we probably should have asked this question earlier, but can you tell us? And I think we kind of touched on probably many things, but tell us how Datafold specifically solves these problems. You sort of described the problems really well, but would love to hear about what the product does specifically.
Yeah.
And how you've built it in response to those things that you've experienced.
Yeah, absolutely. So I think to describe how Datafold approaches it probably makes sense for me just to outline certain beliefs that I have about the space. And I think the three principles for kind of reliable data engineering that I have is that, one, to really improve data quality, we need to improve the workflow. So not invent tools that would kind of sit outside of workflow and send us notifications, but look at how people go about writing SQL models or modifying SQL models, or developing dashboards, and improve their workflow so that they are much less likely to introduce bugs, and so that it's less painful for them to develop and they can develop faster. The example of that is, right now we pretty much adopted the notion of version control in the data space, right? Maybe even 5 years ago, it was kind of novel, but by now everyone agreed that we should version control everything: events, transformations, even BI tools, right? Even reverse ETL, even event schemas, everything. And so that means we have ability to stage our changes and also have a conversation about the changes in what's called a pull request or a merge request, right? And so if we can catch errors at that stage, this is exactly sort of a circuit breaker where within the workflow you can improve things. And as an example, I think the other principle that's really important is that we have to know what we ship. And it's kind of obvious, and it's kind of humiliating to admit that we, data engineers, Linux engineers, a lot of times we don't really know what we're doing. We think we know our data, but data is far more complex. And, it's not uncommon for us, when we write SQL query with a new data set, just not really knowing what's in there, right? We make certain assumptions. I think this column has a certain distribution, or I think this column actually has values, but a lot of times we actually don't know, and those assumptions are wrong. And if we develop our data products with wrong assumptions, we are just paving the path for bugs and for errors. And so I think it's really important to know the data that you're working with. So examples of how Datafold helps there is, for example, we provide profiling. So anytime you're dealing with any new data set, we visualize all the distributions in the data set, as well as provide you with certain quality metrics. For example, what's the field rate in every column? Is this column unique or not? And that really helps avoid a lot of the basic errors when we are writing code or building dashboards on top of a data set. The other important thing about knowing what you ship is understanding dependencies within data, because the hardest thing is, it's hard enough to understand a given data set, right? But it's even harder to understand where does the data come from, or to understand what is actually the source of a given data set, as well as understanding where it goes. So if I don't understand where it comes from, I might not know how actually it represents my business, right? If I don't know which event, for example, a given table is based on, I may not know exactly what this table is describing. If I don't know who is consuming my data, I'm likely to break something for someone eventually, right? And so understanding dependencies within the data platform is super important, and that's solved with lineage. So Datafold provides column level lineage, which essentially allows you to answer the question of take any given column or table, how it's built, and what downstream data applications such as BI dashboards or machine learning models depend on it. Really, really foundational information. And then finally, I think the third principle is automation. So I think no matter how great your quality checks are or your processes, unless this is so easy to do for people that they don't actually need to do it, it just happens automatically, they won't do it, right? So we can't assume that people will test something. We have to test it pretty much in a mandatory way. And then software, that concept is long, I adopted long time ago, right? So when we ship software, we have CI, CD pipelines that build staging, run unit tests, integration tests, sometimes even UI tests automatically for every single commit, right? So we need to also get to this point with data, because this is the only way to actually be able to catch issues and not rely on people to do the right thing. And so the example of how this comes together in Datafold is that whenever someone makes change to any place in their data pipeline, let's take maybe a SQL table model in dbt or DAX or Airflow as an example, Datafold provides full impact analysis of this change. So basically, we call it data diff. We show exactly how a change to a source code on, let's say, SQL affects the data produced. So let's say I changed a few lines of SQL, and now the definition of my session duration column changed. So the question is how, right? Am I doing the right thing? So we compute that difference, and we show exactly how the data is going to be changing. And we're not only doing this for the script, for the table, for the job that you're modifying, we're also providing a full impact analysis downstream. So we're showing you, okay, if you're changing this table and this column, these are all the downstream changes, cascading changes that you'll see in other tables, and ultimately in dashboards, and maybe also in the reverse CTL applications. And so we can trace how data in Salesforce that gets synced 5 layers down will be affected by any given change to the data pipeline. And that all happens in CI. So we don't need people to do anything. It's basically completely integrated with the CI/CD process. And it basically populates a report back in the pull request so that the developer knows what they're doing, but very importantly, they can loop in other team members and have them have full context about the change. And this is really important because kind of pull request reviews for data engineers is almost like a meme topic, because no one understands what's going on. And it's really hard to get the full context of a change unless you really see what it does, right? So, but now with Datafold, a team can have a conversation about this is what the change is going to do, loop in the stakeholders, and then make sure that nothing breaks and no one is surprised. So that's an example of how Datafold does it.
Gleb, you've been describing for quite some time now, all the different dimensions involved, in data quality. And I think we all understand data quality is just complicated, right? Data infrastructure gets more and more complicated, more moving parts. It's a stack. It's I don't know, we can call it whatever we want, but the only certain thing is that it's too many moving parts that they have to be orchestrated and work together, right? And there are just too many actors that interact with data, and each one of these actors might change something, right, in a very unpredictable way. So my question is, deciding to start building a product and a business around that, right? What's your vision? What's your goal? Let's say from 5 years from now, what you would like to see the product being able like to deliver to your customers. And second, where you start from in realizing this vision, because obviously it's not something that you can build like from one day to the other, right? So I'd love to hear like a little bit of like how you as like a founder of the company and with obviously an obsession around like this problem, you try like to realize this vision.
Yeah, absolutely. So my vision for Datafold is to build a platform that would automate data quality assurance from left to right in 2 dimensions. So the first dimension is the developer workflow. And what it means is, if we consider where Datafold sits now, we're kind of really catching things in staging. So when someone is opening a pull request and they are about to merge the code, how can we catch as many errors as possible before that pull request gets merged, right? And so we can go left from here, meaning that we can detect issues even earlier. For example, as someone is typing SQL in the IDE and plugging into their IDE and provide a lot of the decision support at that point, so that they don't even write bogus code. That's where, again, software industry is moving, right? We have the sort of code auto completion, as well as static code analysis and flagging of all sorts of issues in the IDE. And I think we'll get there in the data space. And we have a lot of the fundamental information to do that. And what we need is to really plug into the workflow and into the tools where people develop those workflows. And then going to the right in the developer workflow also means that once someone ships the code to production, we also are going to provide continuous monitoring and make sure that that code stays reliable, that these data products stay reliable. And to the point of data monitoring, right? I still believe it's very valuable, but we decided to start a little bit to the left of that earlier in the dev lifecycle. My vision for what a good data monitoring solution is, it's not only about detection. I think that's the easy part. The much harder part that I'm excited about solving is the root cause analysis and prioritization. Because again, it's not helpful to receive like 100 notifications about anomalies on a daily basis. We need to basically say, hey, you have 100 potential issues, but really you should focus on these top 3, because this one goes into CFO dashboard, this one powers your online machine learning model, and the other one probably gets into Salesforce. So that's one. And the way you do this is by relying on column level lineage and the metadata of dependencies, basically, because we understand how the data is used. And then the other part is root cause analysis, right? Is it a business issue? Is it a data quality issue? Is it an issue that is isolated in a given ETL job, or is it actually propagating throughout multiple tables, and maybe can we pin it to a source data like an event or a vendor data set? So doing that, again, relying on lineage as well as sophisticated analysis is what we are really excited about doing. So that's the kind of the workflow dimension, right? So kind of going to the left all the way to when people start doing development, and then going to the right into production. Now, the second dimension of what we want to cover is the data flow itself. So right now, if you consider the data flow, ultimately we have source data like events, we have production data extracts, we have vendor data sets, we have other kind of exported data that all gets in the warehouse. Then we have transformation layer, and then ultimately data application layer, meaning BI tools, dashboards, reports, machine learning, reverse ETL. So right now, Datafold really shines in the transformation piece. And then we've already extended into the source data and into the application. So for example, for the source part, the big problem is how do we integrate data reliably in the warehouse? Because everyone is moving data around. And for example, it's very customary to copy data from transactional stores into the warehouse, for example, from Postgres to Snowflake. And doing this at scale is really hard, because you have to sync data from data stores that are changing rapidly at pretty high volume into another data store. And what we've noticed is that no matter whether data teams are using vendors or open source tooling, pretty much everyone runs into issues there. And there has been no tooling in that would help validate the consistency of data replication and making sure that the data that you end up with in your warehouse actually stays reliable. So we've actually shipped about 3 months ago a tool called DataDiff in an open source repo under MIT license that essentially solves this problem of validating data replication between data stores, and does this at scale and really fast. So you can basically validate billion rows in under 5 minutes between systems like Postgres and Snowflake. And so this is how we essentially address the source to target data quality. An example, right? There are more problems there, but this is a really, really major one that we saw. And then if we again shift to the right, from the data transformation layer to the data apps, the core there is to understand how data is used. So once data leaves the warehouse, where it goes and how it's used. And so we've been building integrations with all sorts of tools from BI to data, reverse ETL data activation layer. And that's really important because if you can paint the picture of how every single data point is ultimately consumed, you can catch errors way earlier. So for example, we recently shipped integration with PyTouch, which is a data activation company. And so now if anyone is modifying anything in the data pipeline that eventually affects the sync to, let's say, Salesforce or MailChimp, they will see a flag that that data replication process will be impacted. So that's my vision, sort of like going into the left and right, both in how the data flows and how people work with data.
Mm-hmm. All right, that's super interesting. Let's dive a little bit deeper, like starting from the left. Okay, and you mentioned DataDiff, which is an open source tool that can help you like run very efficiently and fast like diffs between like a source database like a Postgres and a destination like Snowflake. Correct?
Yep.
And you mentioned like you were talking about that, and you said that like it's really hard, no matter what kind of technology or vendor you're using, like to connect the transactional database with data warehouse. It's really hard, like to make this at scale like work without issues. Can you share with us a little bit like of like the issues that you have seen out there around that? Because I think like people tend to take that stuff like for granted.
For granted,
yeah.
Yeah, so basically what happens is you have a transactional store, right? That underpins your, let's say, microservice or monolith application. And that transactional store gets a lot of writes, so a lot of changes to data. And then you're trying to replicate this into analytical store, which may not be actually that great with handling a lot of changes, right? It assumes you just append data. And the way that typically those replication processes work, both for vendors and for open source tooling, is relying on what's called change data capture event stream. So every time anything changes in the transactional store, it would emit an event that, for example, a given value in a given row is changed to a certain value, right? And then all of these events are transported over the network using different streaming systems into, let's say, your analytical warehouse. And so the types of issues that can be is as simple as event loss. So sometimes these pipelines build on messaging systems that are not guaranteeing, for example, the right order or exactly once delivery. And if that is the guarantees that you lack, then eventually you may have certain inconsistencies. You just have to accept that there's a happening. The other type of issue which is very common, is soft deletes. So, or hard deletes. For example, if a row is deleted from a transactional store, making sure that it's also deleted from the analytical store where it gets synced is actually a pretty hard problem, because the change data capture streams might not be able to capture that. And so these are just two basic examples of when things can go wrong. And then you have infrastructure layer on top of that, right? So what if you have an outage in the event stream or a delay in an event stream? How do you know that, what data is impacted? And the reason why it gets harder or even, critically important is because transactional data is considered sort of source of truth, because if you have a table that kind of underpins your production system and you record users in it, you kind of rely on that as your source of truth about users, because everyone knows events are kind of messy and lossy. And so if that data becomes not reliable in your analytical store, then you kind of lost all your last resort data sources. And that's why it's really paramount for data teams that they keep that data really reliable.
Mm-hmm.
And what makes things complicated is how do you approach data quality there is that how do you check that data is consistent, right? Let's say even if you think your replication process is reliable, right? We know that all things break eventually, but how do you make sure that they are consistent? How do you measure consistency? It's actually a very hard problem because you might have a billion row table in Postgres, a billion row table in Databricks or your data lake. So how do you check the consistency? You can run count star, but that just gives you a number of rows, right? And validating consistency across that volume of data and being able to pinpoint down to individual value and row is very hard. And it's very hard to do it in a performant way because you can't also put a lot of load in your transactional store. And so the way that DataDiff solves it is by relying on hashing, but doing it in a pretty clever way where obviously if we hash both tables and we compare hashes and there is any kind of inconsistency, we'll detect that. But the other problem is that the hashes won't match if you have one record out of billion missing, and they won't match if you have a million records missing, and you won't know what's the magnitude of the inconsistencies. And so that's why we're not doing just a single hash. We're actually breaking down tables into blocks, and then checking the hashes in those blocks, and then pretty much doing a binary search to identify down into individual row where the data is inconsistent. And so what you achieve with that approach is both speed. So you can diff, billion rows in under 5 minutes, but also accuracy. You can pinpoint down to individual rows and values that are off. And it's a really hard balance to get right. So we're really excited about that tool.
That's awesome. And let's say I'm a data engineer and I hear about this amazing DataDiff tool, right? How do I incorporate it in my everyday work? Let's say I have a typical scenario with Postgres, using Debezium, Kafka, writing on S3 and loading the data on Snowflake, right? I would assume that this is a very typical setup out there.
Definitely.
Many things come. Things there's latency, first of all, right? There's no way that at the same time that something happens on Postgres will also be reflected on Snowflake. So I have this amazing new tool, and I can use it. So how do I become productive with it? How do I incorporate my workflow?
Yeah, absolutely. So when you're dealing with streaming data replication, there is no way around pretty much watermarking. And by that, I mean sort of drawing the line and saying that all the data which is older than this timestamp should be consistent, right? Because we do expect lags and delays. And that's the first thing. Once you establish what the watermark is, then you just basically say, okay, I expect data as of certain timestamp to be consistent. You connect DataDiff to both data stores, and we use typical drivers for that, so Postgres, let's say, and Snowflake. And then you can run DataDiff process, which typically takes within seconds or minutes. And then ideally, because we're talking about continuous data checking, you would run it on schedule. So probably you would want to wrap it in some sort of an orchestrator like Airflow or Dagster, and run it every hour, every day, or every minute, depending on your SLAs for quality. And it's essentially a Python library that also has a CLI. So it's really easy to embed in a data orchestrator, or you can even run it in a cron job. So that's also quite doable.
All right, that's great. And actually you give me the right material to move to my next question, which is about developer experience and the importance of the data engineer in this whole flow of like managing data quality, right? Like, again, I won't like to repeat that, although I might start getting like a little bit like boring, but data is something that can go wrong for many different reasons, and because it interacts with so many different actors. So when I say actors, I mean like actual people, like the CFO, I don't know, made a mistake on the query or like whatever clicked, or our S3, which is like, I don't know, like let's say eventually consistent, like when we got a snapshot from the data there, it wasn't that consistent at that point, or whatever, right? Like there are technical reasons, there are like human reasons that might touch that. So, but the role of the data engineer at the end is like the person who is responsible, right? Like to deliver, let's say, like safeguard like the infrastructure and also the quality of the data. So what I hear from you when you talk is that you put like a lot of effort in like building the right tooling specifically for like data engineers, right? It's not like you are building, let's say, a platform that it's going to be used by an analyst or like someone who only knows like what Excel is and like doing like stuff on Excel or like whatever. We are talking about data engineers here. We are talking about developers. We are talking about people who have like a specific like relationship with software engineering. You mentioned, for example, like CI/CD best practices there, and like pull requests and like GitOps and like all that stuff. So first of all, I'd like to hear from you why you believe that like the data engineer is like so important in realizing your vision behind like the product and the company, because unless I'm wrong, right? So correct me if I'm wrong.
Yeah, Kostas, you bring up a really great point. I think, yes, the reality is that it used to be, even 5 years ago, that data engineers would be people who would own the entire data pipeline, and they would build everything, be responsible for everything, and would have control of everything. As you point out, the reality now is very different. So we have people on the left of the data, right? So software engineers contributing a lot with, instrumenting events in the microservices, as well as, the tables that we talked about, I copied from Postgres. Ultimately, software engineers own them, right? And software engineers might not actually have the context. And then to the right, we have less technical people who are on the data consumption side, and analysts, analytics engineers, and then even people from other teams like financial analysts that now kind of have to become familiar with data pipelines because they need to rely on analytical data to get their job done. And I think the right way to think about what Datafold ultimately solves improves is the workflow of a data developer. And I define this really broadly, right? So it can be a software engineer who defines an event that eventually gets consumed in analytics, or it can be a financial, FP&A analyst who contributes to a DBT job because that informs how they build financial model. I think the reason why data engineers and analytics engineers are really central in this conversation is that even though multiple teams contribute to data, ultimately still that is the persona and that is the team that defines the majority of the data stack and how data is consumed and produced. And they are almost center of the collaboration around data. And so giving them tools that would empower them to do their job faster is really important. But what Datafold does actually goes beyond that. And it goes into the true, I don't want to say like a corny phrase, but I'll say it, data democratization. Because if it's so easy to test any change data pipeline, no matter who does it, software engineer, analytics engineer, data analyst, or data engineer, then it's much easier and less risky to involve other folks, other teams to collaborate on data pipeline than before, right? And one of the worst bottlenecks we're seeing in companies and data-driven companies is that data engineering teams become really bad bottlenecks for their business because, data scientists cannot build ML models unless they have clean data. And so they push down that data creation data engineers. And then data engineers don't let other people contribute data pipelines because they're afraid that people may break stuff. And so they basically become this bottleneck, get overworked, and the business doesn't move as fast as possible. And so if we make change management and data testing so easy and so, easy and automated, regardless of who is making the change, right? Then anyone who touches data will do a better job, and we will be catching errors for everyone. So basically, we're able to elevate the data quality throughout the pipeline, and we can help the business move faster because more people will be able to reliably contribute to building of data applications. Does that make sense?
Yeah, absolutely. And one last question from me, and then I'll give the stage back to Eric, because I'm sure he has many questions, and we have to also mention that, as you say, like there are many people that they are touching the data inside the organization, and like probably one of like the most dangerous one is marketeers, right? And they really won't like to touch the data. So we need to hear from Eric and his experience of like ruining data around, right? But before we do that, Gleb, like one last question, which is like a little bit of like a selfish question, like as a product person that builds like stuff for developers and engineers. Can you share with me, like based on your experience so far, like what is like something that really important to keep in mind when you're designing an experience and the product for a developer and an engineer? Like what is like, let's say, the first thing that you bring in your mind when you start like brainstorming about a new tool for data engineers?
Yeah, I think there are. It's hard to say like what is the most important thing, but I'll probably call out a few.
I think better.
Yes, I think one, and I think you called it out, Kostas, is that data stack is so heterogeneous, right? There are so many tools, so many different databases and data application frameworks. And how do you generalize your product so that you work as equally well as possible with most of them, right? How do you distill your vision to certain principles and patterns that could work with any tool, and it would allow you to build, especially in the data quality space, improve the workflow regardless of what stack people are using, right? And ultimately, you will inevitably have to focus on certain stack. For example, Datafold really focuses on what is called modern data stack. So cloud data warehouses or really mature modern data lakes, right? Like what you can get with Trino these days, that are really kind of almost kind of self-serve, right, for data teams, as opposed to more legacy systems, right? So we have to make these calls. But even if you limit your scope to modern data stack, it's still really hard. And I would say we really cracked this, but I think we so far did a reasonably good job. I think the second problem is, how do you integrate in the workflow of data engineers? Again, given that different teams go about things in different ways. For example, if you want to do any kind of testing before production, then you have to rely on teams having version control for their pipelines, as well as having a staging environment. Because if you don't have staging, there's nothing you can test, right? So you have to basically take the new version of code. Doesn't matter if it's DBT code, Looker code, or PySpark code, and basically test it, right? The way Datafold does it is by comparing it to production and showing you exactly how things are going to be changing, right? But data teams may be building staging in so many different ways. Sometimes they may be using a synthetic data. Sometimes they're using production data to build staging. And so how do you generalize is a really big problem. And so again, finding common patterns that would be most applicable to most teams. And sometimes it means betting on maybe less popular ways of doing things, but betting that those things eventually will become mainstream. One example of that, actually, that tough trade-off that we had to make is, so if you consider how data transformations are orchestrated these days, the most popular tool is Airflow, right? Used by perhaps hundreds of thousands of data stacks in the world. And then there's also dbt, which is an emerging tool, which is a more modern approach to building that, as well as maybe Daxter. But those tools have orders of magnitude smaller adoption than Airflow. And we had to make a call early on to actually not focus on building data quality automation for Airflow. We still support it, but not as deeply as we would support, let's say, dbt. And the reason is that with Airflow, it is very, very hard to build a reliable staging environment. Just the way the tool works, it almost kind of forces you to test in production. And so that makes it really hard to work and implement any kind of like really reliable change management process within Airflow. Whereas with tools like Daxter or dbt, development and staging environments come with a tool. And so it's really easy for us to come in and actually build on top of that. And these are really hard calls because by the time we started, prioritizing integrating with dbt and Daxter, it wasn't apparent that they will actually win. We just thought that their approach is actually the one which eventually will take over because it's more robust and more reliable. But it was a really tough call to make.
Super interesting. Eric.
Yeah, that is fascinating. I have more questions on that, but if I got into that, Brooks wouldn't be happy because we do have to end the show at some point. Gleb, I have a question about the adoption and implementation of Datafold or technology like Datafold in the life cycle of a company. And I'm speaking from experience here as a marketer, to Kostas's point, who has messed up a lot of data.
Yeah.
And messed up a lot of reporting by sort of introducing new data. And I'll explain the question like this, and actually, even with just sort of a personal anecdote with my experience, multiple different companies, you're growing really fast, or, you're launching some new data initiative, and you have, limited resources that are working on that. And, say it's an analyst and maybe you're borrowing some engineering time. You don't have like a fully formed data team yet the company's growing really quickly. In many ways, it's almost like what you described at Lyft, right? Where like data is the lifeblood of the company, but, that's growing so fast that everything seems to be on fire. And what's difficult in that situation is to slow down enough to implement both the processes and discipline it takes to sort of change your workflows, like implement new tooling, etc. Because you're moving so fast. And it really is a challenge because you inevitably create technical debt later on. So you wish you would have done it. But when you're in the moment, it's hard to, it's hard to be that forward thinking because you're dealing with what's right in front of you. How do you see that play out with your customers? How have you dealt with that? And do you have any advice for our listeners who are thinking about that very challenge where it's like, wow, I would love to implement this, but it's just really hard for where we're at as a company.
Yeah, I would say ultimately it's not even about Datafold. I think this comes down to how a company and a data team thinks about putting together the data stack. And I think it comes down to doing the right amount of tinkering. And by that, I mean that if you look at the modern data stack today, you have really great tools that take care of most of your needs, kind of ingesting data, moving it around, transforming it, processing it. And you really can assemble a stack in such a way that it just works. And then you spend your time thinking about business metrics, thinking about analysis, and how to drive your business forward. And then what is probably not the right way to go about this, or some of the mistakes I've seen teams make, is then when they think they, for some reason, need to tinker more than they actually do, like they would start adopting, like take open source projects and start running them in-house because they think they will save costs or because they think they need control. They would be, kind of afraid of vendor lock-in. And sometimes it's premature optimization. Sometimes it's kind of engineering ambition out of control. So kind of tinkering just right amount, right? So if the data team is adopting all the good tools and focuses on like the things that they should be focusing on, that's great. And in that world, Datafold is extremely easy to implement because we integrate with the standard modern data stack tools. The integration takes like about an hour, and you basically improve your workflow in a day. So you connect, let's say, dbt Cloud, like GitHub, your warehouse, and things are just working out of the box. So it's actually not hard. You don't need to, spend a lot of time writing tests or anything. Where you may have run into longer implementation times is when, let's say, you have like a really legacy data platform, or you have a really unorthodox stack for some reason, where you build a framework internally that kind of has like a certain patterns that are not common. Then you will probably use our SDK as opposed to like turnkey integrations, and that may turn into like a longer implementation project. But all of that is to say that for a data team on modern data stack, using best practices, Datafold is extremely fast to implement. So I don't think, unlike assertion tests where you do need to invest a lot of time to writing them, Datafold, or like the regression testing capability is actually really fast to implement. So you don't have to choose between moving fast and moving fast and kind of having reliable data. You can have both. So you can move fast with stable infrastructure.
Love it. That is super helpful. Well, Gleb, this has been such a wonderful conversation. Super helpful. We've learned a ton. So thank you for giving us some of your time to talk about Datafold and data quality in general.
Thank you so much, Eric, Kostas, and Brooks. Also, really appreciate you asking really kind of deep questions and helping me clarify my thinking. So really enjoyed it as well.
Thank you, Gleb. It was great.
Awesome show. Welcome to the Data Stack Show prequel, where we talk about the show that we just recorded to give you a teaser. Kostas, this was a super interesting one talking about data quality. I guess the first question I have is actually related to an accusation that you made, which is that marketers are generally one of the root causes of data quality issues in the data stack. What say you?
Yeah, dude, like just think about like how many shitty tools and like products have been built out there just like to satisfy like the need of marketeers. I mean, that says everything. Like
you can never satisfy us.
and you cannot get satisfied. So I mean, what can I do? I just speak the truth. You know that.
No, it's so true. It is so true. I do think Gleb made a really good point, though, in that he was really forward about data being messy, right? Especially things like event data, which marketing relies on super heavily. And one of the concepts that he talked about that I think was really helpful, and for any one of our listeners who's interested in data quality, you're going to want to catch this show to hear Gleb talk about classifying data quality issues in terms of like we mess something up or they mess something up, which I thought was super interesting. They mess something up are things out of your control, right? So you have like a scheduling challenge in your orchestration tool or something along those lines, right? Which is sort of the they problem. And I think Gleb did a really good job of articulating why a lot of the issues are actually like we problems, like we made some sort of mistake, whether that was, not doing a good enough job on QAing or building an extensible enough system or whatever. And that really informs, I think, the way that he has built Datafold as a tool. So that really stuck out to me. But what do you think?
Yeah, absolutely. I think like it's a very interesting framework to use in order like to capture the complexity of such a complex problem like data quality, because you need like some kind of model and framework to tackle like the problem of data quality. Okay, maybe it's a little bit like dangerous in some environments. The we and them situation might get a little bit spicy. But it definitely works well like for him, who's building like a product and a company, and he needs like to create, let's say, at the end, like product experiences, but they are going to be consumed like by very different like people, from data engineers to like people who are consuming the data at the end, and probably they're not like technical at all, right? But they are part of the problem and part of the solution too of data quality. Yep. So yeah, it makes a lot of sense. I don't know, like I really enjoy like the conversation. I think it's like for me also gives like more joy the fact that they have a very developer focused approach, like the products that they are building. So that's something that like I find always like very interesting.
Yep.
I mean, at the end, yeah, like okay, like data quality is a very hot space. We have like quite a few vendors, like probably we brought here most of them.
Yeah, a lot of the big ones.
Yeah, and I think we should do another iteration in a couple of months, like bring all of them again and see like what has changed with each one of them.
Yeah, absolutely. Well, you're definitely going to want to catch this one. Super interesting if you're working on anything related to data quality. If you don't like it, don't worry. That's a we problem, not a they problem. And of course, we will catch you on the next show. Thanks for joining us, and subscribe if you haven't.